Hi everyone, welcome to the lecture number 12, which is the fourth lecture on labor demand. In our last lecture, we discussed about the elasticity of labor demand. We also discussed about the Marshall's rules of derived demand and how it affects through the union behavior. Although we have assumed that the production function has two inputs, labor and capital, we can easily extend this theory to account for more realistic production process. So, we can extend it to n number of factor inputs. There are clearly many different types of workers such as skilled, unskilled. There are many types of capital such as old machines, new machines. So, if we can extend this production function, then we can write this production function like here we have taken the equation where Q is the output is a function of number of factor inputs and it range from x1, x2, x3 to xn. Now, this hiring inputs decision of a profit maximizing firm, as we had already discussed, the optimal combination of inputs, the optimal amount of any factor input will be employed to the process of production, where the marginal product of that factor or the value of marginal product of that factor equals to the price of that factor input. So, each of these xi's will be employed up to the optimal point where these factor inputs, the value of the marginal product of these factor inputs equals to their cost. All the key results derived from the simpler case of two factor production model continue to hold true when we extend it to n number of factors of production, like the short run and long run demand curves for each inputs are downward sloping. The long run demand curve is more elastic than the short run demand curve, and a wage change generates both substitution effect and a scale effect. However, one common empirical findings is that labor demand for unskilled workers is more elastic for skilled workers as compared to the skilled workers, which means for any given percentage increase in the wage, the cut in the employment will be larger for unskilled workers than for the skilled workers. An interesting interpretation of this result is that employment is inherently more unstable for unskilled workers than for the skilled workers. When various economic shocks shifts the ways of these two types of workers, the number of workers demanded will fluctuate significantly among the unskilled workers, but much less fluctuation will happen among the skilled workers. Further, the presence of many inputs in the production process raises the possibility that the demand for input I might increase when the price of input j increases, but it might fall when the price of input k increases. So, the demand for these factor inputs are interlinked with each other. Now, to measure that how the demand for one input is responsive towards the price of the other inputs is called the cross elasticity of factor demand. So, to measure the sensitiveness in the demand for a particular input to the price of other inputs, we called it cross elasticity of factor demand. So, we can measure this cross elasticity of factor demand. It is nothing but it is the percentage change in the xi, means quantity demanded for the factor input x, with the percentage change in the price of the factor input j. So, the cross elasticity of factor demand gives the percentage change in the demand for input I resulting from 1% change in the wages of the input j. Now, if you look at this estimation of this cross elasticity of factor inputs, the sign of the cross elasticity provides one definition of whether any two inputs are substitute or complement in the process of production. Now, if the cross elasticity is positive, so that the demand for input I is increasing when the wage of the input j increases, this means these two inputs I and j are substitute in nature. After all, the increase in Wj increases the demand for input I at the same time, and it reduces the demand for input j. So, the two inputs are substitutes because they respond in different ways to the change in the wage. So, the farm is getting rid of more expensive inputs and replacing it with relatively cheaper inputs. If the cross elasticity of factor demand is negative, the demand for input I falls. As a result, the increase in the Wj and the input I and j, they are called complementary to each other. So, the inputs are complements when both responds exactly in the same way as there is a rise in the wage of the factor input j, which means these two inputs, they go together. Now, here you can see how there is a shift in the demand curve for the factor of production, which is affected by the price of other inputs. Now, the demand for factor input I shifts up when the price of input j increased. The demand for factor input I goes up. So, in this case, this I and j, they are substitutes in nature. Now, if the demand curve for factor input shifts down when the price of input j increased, in this case these two inputs are called complementary. There are a number of empirical studies which suggest that the unskilled labor and the capital, they are substitute in nature, whereas the skilled labor and the capital, they are complement in nature. As the price of the machine falls, the employer substitutes away from the unskilled workers, whereas in contrast, as the price of the machine falls, the employers increase their use of the capital equipment, and the demand for skilled workers rises because the skilled workers and the capital equipment, they go together. So, the skilled workers and the capital, they are complementary in nature, whereas the unskilled workers and the capital, they are substitute in nature. So, this result has come to known as the capital skill complementary hypothesis. This capital skill complementary hypothesis has important policy implications. It suggests that how the labor and capital, they substitute. It suggests that subsidies to the investment in the physical capital, such as investment tax credit, will have differential impact on the different groups of workers. Now, when we say subsidies to the investment, we are saying that the price of the capital is declining. We are lowering the price of the capital to the farm, which means it increases the demand for capital and reduces the demand for unskilled workers, and it will increase the demand for skilled workers. Therefore, an investment tax credit, it increases the investment in the economy, but also worsens the relative economic condition of the less skilled workers. There will be more unemployment among these less skilled workers. So, the capital skill complementary hypothesis also suggests that the technological progress such as substantial reduction in the price of the computing power in 90s and 80s can have a substantial impact on the income inequality, which means when the technological replacement has happened in the computing power in 80s and 90s, there is an increase in the demand for the skilled workers and it has reduced the demand for unskilled workers. So, the income is now more polarized towards the skilled workers and income has reduced for the unskilled workers. As a consequence, we can see there is a wide increase in the income inequality. So, this capital skill complementary hypothesis may lead to income inequality in the economy. Now, before getting into the policy applications on the labor demand, let me discuss on the overview of the labor market equilibrium. We have analyzed the factors that encourages the workers to supply a particular number of hours to the labor market and that encourages the firm to demand a particular number of workers. So, labor market is the place where the workers looking for jobs and the firms they are looking for workers. Finally, they meet each other and compare the wage and employment offers. So, the interaction between this worker and the firms that occurs in the labor market determines the equilibrium wage and employment level in the economy. The wage and employment levels that balance the number of hours that workers wish to work with the number of employee hours that the firm wish to employ. In this section, we will briefly discuss about this equilibrium. However, we will discuss the properties of this labor market equilibrium in more detail in our future lectures that deals with the labor market equilibrium. So, if you look at this graph, on this x axis we have taken the number of employment, on the y axis we have taken the wage which is measured in terms of dollar. We have considered the supply curve which is upward sloping, which means the substitution effect is more dominant than the income effect. We have drawn the demand function for labor which is downward sloping, and this interaction of this demand and supply in the market decides that W star is the wage rate and E star is the amount of employment, number of workers employed in the labor market. Now, this W star wage rate which we call the market clearing wage rate, where there is no excess labor, there is no shortage of labor. Now, if at any point of time the wage is high, which is much higher than this W star market clearing wage rate, then what happens? In the labor market, the demand for labor is ED amount of labor is demanded by the firm at this high wage rate, whereas at this high wage rate ES amount of workers are ready to supply their labor hour. So, there is an excess supply of labor, which means there is a large number of queue which is there before the employers, which will tend to the employer to reduce the wage rate until it reaches this point W star. So, this excess supply of labor will induce certain force on the wage to come down. Similarly, when the wage rate is lower than this market clearing wage rate W star, so the demand for worker is much higher than the supply of worker, which means there is a shortage of worker, which will induce the wage rate to go up and settle down at W star. So, both employer and employees, they find the optimal level of wage and employment with the interaction of this demand and supply. and this wage and employment determined in a competitive market. So, once the labor market attains the equilibrium wage, this conflicting wishes of the employer and workers have been balanced, and at this wage the number of workers who are looking for work exactly equals to the number of workers that the employer wants to hire. In the absence of any other economic shocks, the equilibrium level of wage and employment can then persist for an indefinite period of time. Now, considering this situation in mind, let us discuss about certain policy applications, how it affects the labor demand and how it affects the production cost. There has been a great deal of debate about the economic impact of the affirmative action programs in the labor market. These affirmative action programs typically encourage the farms to alter their workforce with respect to the race, ethnicity, gender. The farms, they try to balance it by hiring relatively more of those workers who have been underrepresented in the farms hiring in the past. So, let us suppose a affirmative policy action which might require that the farm hire only one black worker for every two workers it hire, which means it has been, let us say, suppose it has been observed that black workers have been underrepresented in the farms hiring process. So, a policy, affirmative policy action has been implemented that the farm has to hire one black worker for every two workers. Now, what will happen? Let us try to understand to the production of the farm or the optimal mix of inputs the farm required to produce a fixed level of output with this kind of policy, affirmative policy actions. Our theory of how farms choose the optimal mix inputs in the production process helps us to understand the nature of the debate over the employment impact these programs. To simplify the discussion, suppose let us take into consideration that there are two inputs in the production process. One is black workers, another one is white workers. In this example, we will ignore the role of capital plays in the farm's production. So, by ignoring that factor input, we are simplifying the model, and this simplification will allow us to represent the farm's hiring choice in terms of this two-dimensional iso cost and iso quants in our that we had already derived in our earlier section. So, with the help of iso quants and the iso cost, let us try to understand that how this affirmative policy action will impact the farm's production cost. Suppose the black and white workers are not perfectly substitute, so that the isoquant between these two groups will have the usual convex shape. We are assuming that they are not perfectly substitute because these two group of workers might have different productivity because of their different they differ in the amount and the quality of educational attainment, number of years of education and the quality of education. So, productivity may differ from that perspective, or because they come from different occupations and they are entering into the farm with different types of job trainings, past experience. So, these are the factors which brings the difference in the productivity. So, we are assuming that they are not perfectly substitute. Further, a competitive farm can hire as many black workers as it wants at the going wage rate WB and can hire as many white workers as it wants at the going wage rate WW. A farm, we are assuming that it is color blind, means it does not discriminate whether it is a black worker or it is a white worker. Now, let us consider that if the farm is a color blind farm, if the race of the worker does not enter into the hiring decision of the farm at all, so the profit maximizing color blind farm would then want to produce a Q star unit of output in the most efficient way possible, where the isoquant is tangent to the isocost. So, if we draw, we try to find out that what is the optimal combination of black and white workers should be employed in order to produce a fixed amount of output by the farm, which is Q star. What is the combination of black and white workers the farm should employ? So, here on the x axis we have taken white workers, on the y axis we have taken the black workers, number of black workers to be employed, and to produce Q star unit of output, WW wage rate for the white labor and WB for the wage for the black labor. This is the isocost line, and this isocost line tangent to this isoquant at point Q, which means the farm is hiring this much of black workers and this much of white workers in order to produce Q star amount of output. Now, suppose the farm discriminate against the black workers, which means the farm's management gets disutility from the hiring of blacks and would rather see white workers filling most jobs in the farm. Therefore, the farm is prejudiced. The farm's prejudice alters its hiring decision. So, a discriminatory farm will not want to be at point Q, because at point Q he is employing more black workers as compared to the white workers. So, a discriminatory farm will not want to be at point Q, but instead will choose to operate at in a point where this input mix that has more white workers and fewer black workers to produce the same level of output. If you can see in the figure, let us say the point P. At this point, it is important to note that this employment discrimination moves the farm away from the input mix where the isoquant is tangent to the isocost. So, the farm is moving from its optimal point where it should hire the combination of black and white workers, the point Q. The farm is moving from point Q to point P. So, this prejudiced farm has simply decided that it is going to ignore the cost minimizing rule, because that rule generates a wrong color mix for the farm's workforce. So, as a result, the input mix chosen by the farm at point P is no longer at the point where the isoquant is tangent to the isocost. After all, the slope of the isocost is given by the ratio of the wage rates. It is nothing but minus WW by WB, and a competitive farm cannot influence the wage rate. So, when the farm is moving from point Q to point P, it is not going to operate in the same isocost. So, you can see when the farm move from this point to this point, the isocost function definitely is going to be higher than the previous one. So, rather operating at this point Q, where the farm should have hired this much of black workers and this much of white workers, the farm is discriminatory. The farm discriminates the black workers. So, the farm is going with the prejudice that he should hire this much of white workers and this much of black workers, so that he will operate at point P. The output is fixed. So, definitely this combination of factor inputs are going to force the farm to operate on a higher cost function. So, point P does not lie on the lowest isocost that would allow the farm to produce Q star units of output, and this prejudiced farm uses the input combination that cost more than the input combination it would have been chosen had it been a color blind farm, non-discriminatory farm. So, our theoretical framework therefore leads to a very simple and surprising conclusion that discrimination is not profitable. So, if the farm is discriminating, then the farm is operating at point Q, which is not at the lowest cost. Now, suppose the government forces the farm to adopt an affirmative action program that mandates the farm to hire relatively more black workers. So, this policy moves the farm's employment decision closer to the input mix that a non-discriminatory farm would have chosen, which is point Q. In fact, if the government fine tunes the employment quota that just right exactly, it could force the discriminatory farm to hire the same amount, same input mix as the color blind farm or non-discriminatory farm at point Q. So, if you could able to frame the policy in such a way that we can force the farm to operate at point Q, then this kind of affirmative policy actions will have benefits to the economy as well as to the farm. While talking about this kind of affirmative policies, there are two interesting consequences. First, the farm's workforce has relatively more black workers now as compared to previous, and second, because it costs less to produce a particular level of output, the farm is more profitable operating at a low cost function. In short, this type of affirmative action policy leads to more efficient allocation of resources. The reason is that the discriminatory farms are ignoring the underlying economic fundamentals. So, in particular, these discriminatory farms, they disregard the information provided by the cost of hiring black workers and the white workers when they make their hiring decision, and instead they go with their feelings. So, affirmative action policies would then force discriminatory farms to pay more attention to the prices of the factor inputs. Now, before we conclude that the widespread adoption of affirmative action programs would be a boon for a competitive economy, it is important to recognize that the example which we discussed here, we discussed through a particular prism. We are assuming that the competitive farm is prejudiced, the competitive farm is discriminatory, so that the farm's hiring decisions are affected by the discrimination. Now, what if the farm is not discriminatory, but by chance it is finding the mixed input which will be used to produce a fixed level of output is more favorable towards the white workers. So, it is needless to say that there is an alternative viewpoint, one that leads to a different implication. Suppose in particular the farm in the labor market do not discriminate, as I said, and suppose further the shape of the farm's isoquant is such that the farms hire relatively fewer black workers, and if the black and white workers are equally cost. So, if this is the case, the farm is non-discriminatory farm and the farm operates at point P by chance to produce this Q star level of output. So, point P is maximizing its profit by hiring this much of black workers and this much of white workers. So, by default it is coming out that the farm is going to hire less black workers in order to maximize its profit. So, if this is the case and we are going to have an affirmative policy action which is more in favor of the black workers, what is going to happen? Suppose the government again mandates that the farm hire relatively more black workers, and this policy forces the farms to move from this point P to point Q. So, point P is the cost minimizing solution. From there, because of the government has forcefully come up with this policy, the farm has to hire a fixed amount of black workers, then the farm is forced to move to the point Q. So, a point Q where this isoquant is not tangent to the isocost. Therefore, this affirmative policy action increases the farm's cost of production. Therefore, it is clear that the initial conditions assumed here determines the inference that one draws about the labor market impact of these affirmative action programs. So, if one assumes that the typical competitive farm discriminates against the workers, the affirmative action program forces the farm to pay more attention to the economic fundamentals and increases the farm's profit. In contrast, if one assumes that the typical farms does not discriminate and an affirmative action program may substantially reduce the profitability of the competitive farm and perhaps drives many of them out of business. So, as this discussion shows that our perception about the real world can greatly influence the position that we take in the debate over this labor market impact and the affirmative action. So, if the farm is already a kind of non-discriminatory farm, putting this kind of policies may lead to different consequences. So, in our next lecture, we will discuss more on the policy applications on this labor demand. We will discuss about the minimum wage, the impact of minimum wage and the labor demand. Thank you.